In this part of the lesson, we are going to continue with the Pythagorean Theorem, and Pythagorean Theorem can also help you classify triangles. Okay, so question number one is asking, is the Pythagorean Theorem going to work in any case? That means any type of triangle. Okay, so we don't know if this is the right triangle. Can we apply the Pythagorean Theorem to this triangle? And the answer to this question is we can't. Okay, it's not possible. And so the next question is, for what type of triangle is the Pythagorean theorem going to work? The answer, as you know, is it has to be a right triangle. Okay, so if it's not a right triangle, we cannot apply the Pythagorean theorem. However, we can use the Pythagorean theorem to help us classify the triangles. Okay, so what happens if this c squared does not equal a squared plus b squared? For what kind of triangle is this c squared less than a squared plus b squared? The answer to that question is for acute triangles. So if once you apply the Pythagorean theorem to the three given side lengths for a triangle, and you end up with the hypotenuse square being less than the sum of the square of the legs, you have an acute triangle. Well, what if you end up having greater than, okay, instead of less than? In that case, you have an obtuse triangle. So as you can see, the Pythagorean theorem can help you determine if you have a right triangle, an acute triangle, or an obtuse triangle. And so it'll help you classify those triangles as either one of those three. So I'm going to give you three examples on the next part of the lesson. Okay, so the first example is, this is asking us to classify the triangles with the given side lengths using Pythagorean theorem. So as you can see, I have the Pythagorean theorem here stated. Okay, so the side lengths we're given are 5, 6, and 10. And obviously the longest side is 10, so that has to be the c value or the hypotenuse. Okay, so then I'm going to substitute. Okay, so is 10 squared equal to 5 squared plus 6 squared? Now we know that 10 squared is 100, and 5 squared is 25, and 6 squared is 36. And if we add 25 and 36, the sum is 61. But we also know that 100 is greater than 61, so now we have this case here. Okay, since this happens, then we can classify the triangle as an obtuse triangle. And I hope that makes sense. So there's example number one. Example number two, we're given side lengths of 20, 21, 22, and 29. So then my question here, I have a question mark because I don't know if this is going to be equal to. So let's see. Longest side is 29, so that's our c value. So then 29 squared, 21 squared plus 22 squared. Notice that I didn't write an equal, less than, or greater than, because we don't know yet. But once we're done with this calculation, we'll be able to determine. So 29 squared is 881, and 29 squared is 841, and 21 squared is 441, and 22 squared is 484. And if we add 441 and 484, the sum is 925. And as you can see, this is 841, which is less than the sum of these two. So our conclusion is that we have something like this one here, okay? Which means we have ourselves an acute triangle, or we can classify this triangle as an acute triangle. Let's go on to the last example here. So again, you have square roots here, but still the Pythagorean theorem is going to apply. Maybe you have a challenge here trying to determine, well, which is the hypotenuse? Think about it. This is 2 times the square root of 7. So the closest to the square root of 7 is the square root of 9, which is 3. So 2 times approximately 3 is going to be 6. This is the square root of 61. So the closest to 61 is 7. So this one is 7 point something, right? But this is 89. The square root of 89, it's closer to the square root of 81, which is 9. So that means this is the longest side. So having said that, I'm going to substitute into this formula. Okay, so the square root of 89 squared, and then is this equal to 2 times the square root of 7 squared plus the square root of 61 squared. So what the square is going to do to the square roots is going to remove the radicals, okay, the radical signs. So then this is just 89. This is 4 times 7 because 2 squared is 4, and the square root of 7 squared is just 7. So this is 4 times 7, and this is 61. So then this is 89. This is 28 plus 61, and if you add 28 and 61, that is equal to 89. So how can we classify this triangle? We classify this triangle as a right triangle. Okay, so I hope that helps you use the Pythagorean theorem to help you determine if the triangle you're working with is a right triangle, an obtuse triangle, or an acute triangle. All right, bye-bye.